Hey there, TouchDesigner developers. Jack DiLaura here with the Interactive and Immersive HQ. In this video, we're going to look at creating another GLSL-based effect in TouchDesigner. This one is an additional conversion from an older ShaderToy-based effect to run in TouchDesigner. And this one is essentially at its core a very simple smoke-like feedback effect, which has some additional changes made to it to produce this cool glitchy look. And we can run things like a webcam feed into it, as well as any sort of generative graphics that we can come up with in TouchDesigner. So this is the shader that we're going to be recreating in TouchDesigner. It's called Glitchy Trails and was created by CutMod back in 2016. It is essentially a slight tweak or adaptation of an earlier shader called Very Simple Feedback Smoke. And really between these two, there's only a couple, maybe 3 lines of code that are different. So I'll post the links to both of these so that you can take a look at them. And we're going to be slightly modifying the code of this Glitchy Trails shader for use in the program, as well as kind of replacing some of the functionality that it contains with TouchDesigner operators. But the core of it comes from this Glitchy Trails shader and also, of course, the Very Simple Feedback Smoke. So as we're starting to transition into TouchDesigner, I just thought I'd point out as well the sort of anatomy of this shader. So we've got in this buffer A code here, the core of this effect. This is really all the code that is producing what we see on our output over here. We also have in our iChannel 0 input the buffer A itself, which is creating a feedback loop, which is, again, a clue that we're going to be working with the feedback top in TouchDesigner. On this image tab, this is just how we're taking the content that is coming from our buffer A shader and then displaying it to the output. So we don't really have to worry as much about this component, but buffer A is really where all of the useful information or the core of the effect is happening. So let's put together, first of all, the kind of basic structure of our effect in TouchDesigner, and then we'll work on the code. So we're going to, of course, need a GLSL top to write the code and generate the texture with. And then, as I mentioned, we're also going to need a feedback top to create the feedback loop that the effect relies on. So in the code for this effect, this was the feedback was being created between iChannel 0 and itself. So that means we can use, in our case, the first input with this feedback top. Now, in the case of the code on ShaderToy, they are actually writing some GLSL to generate a small circular shape on screen and have that kind of automatically rotate around the texture. But instead of doing that, we're going to set up our project so that we can instead generate a texture with any of the TouchDesigner tops that we have available, and then run that into the feedback top and use that to at first initialize the texture or the feedback loop, and then we can also composite it into that feedback loop as well and allow it to further modify the effect. So what I did to get the look that we saw at the beginning was to use a noise top as the initial kind of state of this shader. So essentially, we're going to feed this into the feedback top, and that is going to provide us with the first frame before we start feeding back. So I'm going to connect this to the feedback top, first of all, and then the noise top needs a couple of changes. This effect is going to require us to work in a higher bit depth for it to give us the kind of outcome that we saw on ShaderToy. So first off, I'm going to come to the common page of the noise and set the pixel format here to 32-bit float RGBA. Now that one is important, so make sure that you have set yours to a 32-bit float pixel format as well. I'm going to bump the resolution of this output up as well. I think I'll do something like 1280 by 720 so that I have a higher resolution output and it'll match what will come from my webcam. The other thing that I'd like to do while I'm here is to come back to the noise page, and I don't really like this kind of default state of the noise for this effect, so I think I'm just going to modify this slightly. First by setting the period here up to 20, and then I think I'll also turn the monochrome switch off so we end up with a colorful noise output. I'm going to do my usual translation on the transform page for the TZ component. And I'm going to type in here under TZ ABS time.seconds and multiply that by 0.1. That's going to cause our noise to start animating and give us a slow enough animation that there won't be any changes in the output that are too abrupt, but enough that it will give us a little bit of variety. So that is, again, being fed into the feedback. But another thing that I like to do with this effect to, again, allow us to manipulate what the final effect will be applying, basically manipulate the feedback that we're generating over time, is to add in a composite after the feedback top. So this is where we're starting to kind of differentiate from the original version a little bit. I'm going to add a composite in here, and then I'm going to use this to give us the ability to composite in some other texture. So at this beginning stage, I'm going to use a rectangle for this and kind of copy off of what the original effect was doing with GLSL code. So for the rectangle, I'm going to connect the output of the noise to the input of the rectangle. And I'm doing that actually just so that I can get the pixel format, which you'll see is now set to 32-bit float, and the correct resolution. But I don't really want these two things to be composited together at this point. So I'm going to go to the output page after that and change this combine with input setting to set resolution only. While I'm here, I'm also going to set the size of this rectangle down to 0.1. And I'm also going to set the fill color to some kind of turquoise or maybe teal color. We're going to come back and add in some chop control over the positioning of this in a moment. But for now, I'm going to then connect this to the composite. With the composite, I'm going to set the operation here to over. And then I'm actually going to flip the order of these inputs. Now I could simply hit the swap operation order switch if I'd like, or I can come down here and actually click on the arrow next to rectangle 1 and make sure that that is then applied over top of the feedback. Now you'll see, because I haven't yet reset the feedback, we've still got the original 256 by 256 resolution. That's okay. I can just simply pulse that to get the current state of things. But another thing that I want to do while I'm here is to set a target top for the feedback. So we need to, point the feedback top to the location, the operator that's going to provide us with the link and the frame to create the feedback loop. So I'm going to drag the GLSL1 top onto the target top parameter. That's going to leave us with a white value. And now that we've got this sort of set up, I think we can start to, let's add some chop control, and then we'll move on to the code itself. I'm also going to add a null at the end. This will be my kind of output, my final operator. So I'm going to call this null space out. And now we can move on. So for the positioning of this rectangle, I'm going to have this kind of move in the same sort of circular fashion that we saw in the GLSL code. But of course, I'm going to be doing this via chop channels, and a really simple way to get some synchronized sine waves for creating circular movement is with the beat chop. Normally used for more rhythmic sorts of things, but in this case, we can use it for kind of LFO style control channels. So I'm going to add the beat chop to the network, come to the output page. I'm going to turn the ramp switch off, and then I'm going to turn the sine switch here to on, which is going to generate a sine wave. I'm going to come to the multiples parameter to add an additional channel, and you'll see that those are offset from one another. But I want the phase difference between these two to be a little bit less. And so I'm going to set the shift step here to 0.5 instead. And you'll see now that they are, a little bit closer in the alignment of their phase. For the final positioning of the rectangle, I know that my center position values with the rectangle usually go between negative 0.5 and positive 0.5 at least in the horizontal direction. I'm going to set this so that the center unit here is actually the fraction aspect mode instead of the usual fraction, just because I want to move this in a circle rather than sort of a oval shape. But I know that I'm going to have to reduce the amplitude of this waveform, and I'm going to do that with a math chop. So I'm going to add the math chop in, and then all I really need to do, I don't really need to mess with the range here because we have this maximum and minimum. The peaks and troughs of this sine wave are oriented around the x-axis, meaning that if I simply multiply them by a smaller amount, I can reduce the amplitude and don't have to worry about setting the range page. So I'm going to set this multiplication value down to 0.2, and that's going to enable my output of the sine waves now to fall between negative 0.2 and positive 0.2. Then I can add a null to the end. We'll call this null center, and this is where I'll make a chop reference from these two channels to the center parameters of the rectangle. So I'm going to make the chop reference from the sine 1 channel to the x and the sine 2 channel to the y, and you'll see then that I've got a nice circular movement pattern. Now this is moving maybe a little bit too fast for me in this current state, so I'm going to come back to the beat chop, and I'm going to set the period here to 6. Which will slow things down a little bit. Now that I've got that all set up, this is basically the core of the network prior to the GLSL top that I'm going to need to generate the kind of effect that I'm looking for. However, there is one other handy thing that I'd like to do, which is just to give us the ability to reset the feedback via the keyboard, because as we're kind of playing around with this, things can go wrong a little bit, and it's nice to have the ability to reset that without having to click on the operator itself. So I'm going to grab the keyboard in, chop, and I'm just going to make a simple reference from this K1 channel to the feedback top, and in particular, the reset switch within the feedback top. So once I hit the 1 key on the keyboard, that will reset the feedback for me. All right, so let's finally take the dive into our GLSL code. I'm going to edit the GLSL1 underscore pixel dat in an external code editor by clicking on it and then hitting Control E on the keyboard. I'm going to increase the scale of this a little bit, hopefully to make it easier to see. And then we can get working on our code. So in the original shader, we had a couple of things that we're going to basically remove and replace. So I think what I'll do, just to make this easier than having to type out a million different numbers, is to copy the code from ShaderToy and then paste it, and we'll work through editing it together. So we're going to leave all of the code that came with this operator here because we're going to reuse some of this. But I'll go ahead then and paste in the code from ShaderToy. We can see right away that our main function looks a little bit different. We've got some components in the code that are using ShaderToy specific variable names, so we'll have to change those and set up some uniforms and some other things as well. To start off, we're going to replace this line of code here, or modify this line of code that's setting up this UV vec2. I'm going to actually delete the line above that, which is commented out, because we don't need that one. And then in this portion of the code here that says fragchord.xy divided by iresolution.xy, we're going to replace that with v, lowercase v, uppercase uv.st, which is a built-in component of the GLSL top, which replaces that initial math that we had to do on ShaderToy. So that's a handy built-in component that we can replace immediately. Then if we move right along in the code, this is the section here that I was mentioning that we're going to replace. So this is what was generating the small circles in the ShaderToy code. We're not going to use that, as we are instead using the tops in TouchDesigner to do that. You'll then see all of these texture function calls, which have iChannel0 referenced in them. So that is one of those things that is specific to ShaderToy as well. And in our case, we want to reference a different name, which will point to the inputs available to this GLSL top. So I'm going to do a find and replace for this particular name, just because I don't want to have to type it in a bunch of times. So I want to replace in this upper section iChannel0. I want to replace this with std2d inputs. And the capitalization here is important, so make sure that TD, 2D, and I are uppercase. Then we'll add some brackets and put 0 in between those brackets to point to the first input. And that will be it. So that'll point to the first input of this GLSL top and grab the correct texture for us. So I'm going to hit the replace all button. And there we go. Those have all been replaced. For this iResolution.xy, this is another one of those ShaderToy specific components. We can actually use another one of these built-in TouchDesigner variables to access the resolution of the inputs that are connected to this operator. And what I'm going to do for that is to type in u td2d, again, td2d being all uppercase, and then I want infos this time. I'll add the brackets again with a 0 to access the first texture. And then I want the dot resolution, and using swizzling, I want the Z and W components, which correspond to the width and the height of the resolution of the input. So that has been replaced. That looks good. We'll continue along, and you'll notice here that we have a bunch of iTime variable names added into these different lines of code at the bottom here. And these, again, are another specific thing for ShaderToy, which corresponds roughly to the ABS time.seconds or .frame option in TouchDesigner. So we're going to change this name to something that follows the sort of naming conventions we have in TouchDesigner a little bit. You'll see up here that the built-in names that we're accessing will have a U at the beginning when we're talking about something like a uniform, and this S is corresponding to a sampler for this particular input. So I'm going to be replacing iTime with a uniform. And when we're working with uniforms, we'll see up at the top of the code, we have this commented out section. We need to declare them in order to access them in the code. So I'm going to remove the 2 forward slashes for this uniform float. And I'm going to replace the name of this float, which was example uniform, with U and then time. So U telling us that this is a uniform, and time because we're replacing all of the iTime variable names within this code. Then I'll do a simple find and replace again so that we can get rid of all of these names that no longer mean anything in TouchDesigner. So I'm going to look to replace iTime, and I'll replace that with uTime and hit replace all. The last thing that I want to do with this code, besides kind of fixing the doubling of content that we have here, when we set up our final output of our GLSL shader in TouchDesigner, we want to use this TD output swizzle function. So I'm going to copy and paste that and bring it down to this frag color section of the code from ShaderToy. And I'm simply going to encapsulate this max function here with that TD output swizzle function so that it will apply and send the color out correctly. But other than that, besides that, our final step will be to, we're going to want to replace this void main image function call to match what we have up here, which is simply void main. I'm going to select everything from this curly brace up to the one from the original set of demo code. I'll hit backspace, and then with that, we'll actually have completed the code. So I will, I'll leave this up on screen. I'll kind of zoom out for a second. This will be available in the description for this. We'll have the files available. You can download this if it is too much trouble for you to get working correctly. Of course, the links for the original shader will also be available, so you can copy and paste and follow along as we've done here. But assuming that you've got this all updated correctly in your version of the code, you can then hit save. And if we head back to TouchDesigner, we should almost be ready to roll. You'll notice, however, that we have a little caution flag. If I click on that, I'll see that I have not yet assigned a uniform called uTime. So when we're working with GLSL in TouchDesigner, we have a page here called vectors, which we can use to set up the uniforms. So when we are declaring something in our code, one of these uniforms, we need to then set up in the GLSL top, what that uniform's name is and also the value for that name or for that uniform. And that'll allow us to then connect that uniform in the code to anything outside of this GLSL code. So we can use all of the different operators in our usual sort of TouchDesigner fashion, whether that's a chop reference or something else, and have that modify the shader processing that's occurring within this GLSL code. So I'm going to simply type in uTime for the uniform name, and then I'll set for the value here. I just will set ABS time.seconds. And once that is entered, you'll see that the little caution flag goes away. We've got this component over here that says compiled successfully. And if I take a look at the output of the shader, it is looking very similar, if not identical, to what we saw at the beginning of this video. So in this last section of the video, I just wanted to show you how I actually routed my webcam signal into TouchDesigner and then used that as a part of this effect. So I used the OBS NVIDIA background plugin, which allows you, or actually it might be NVIDIA Broadcast. I can't remember which one it is off the top of my head, but it allows you to use NVIDIA's background removal functionality on the camera signal coming from your webcam. And then I'm sending that over to TouchDesigner via the NDI protocol. Nothing fancy there. I'm using the chroma top to remove the black matte around me. And then I'm running that signal into two separate threshold tops, which are set slightly differently. And these were just kind of tweaked to taste. But basically, I wanted to get like an overall kind of outline of my silhouette and then a little bit more details of my face. And so I've set the threshold settings up accordingly. And then I used constant tops. I just plugged the signal from the threshold into the constant top to apply color to the signal, and then finally composited those two textures together using the over operation. Once I've done that, I can simply plug this straight into this composite, and I want to replace the connection for this rectangle top. So I want this composited webcam feed to be placed over top of the feedback texture. And then we'll see that once I've routed that into this effect, I can then take a look at the final texture and see that indeed my webcam signal is now a part of the output. So this processing that I've done to the webcam feed isn't necessarily required. You could, start from this chroma top and say plug that in instead, but you'll see that it's going to do some recoloring to the signal anyways. So you can work with these threshold effects to get it looking a little bit more stylized, kind of like the glitchy effect itself. So with that, I hope that you have enjoyed putting this together and that it's given you, again, a little bit more insight into working with GLSL in TouchDesigner and really taking shaders that exist already and converting them for use in the program. Also wanted to once again give a shout out to CutMod for the original version of this effect from ShaderToy. And as always, thank you so much for watching. Looking forward to seeing you in the next video.
Hey folks, thanks for watching. If you like our YouTube content, I highly recommend you check out the Interactive and Immersive HQ Pro. The HQ Pro is the only comprehensive educational resource and community for immersive design, TouchDesigner, and creative tech pros. In the HQ Pro trainings, we cover almost any topic you can think of, and we go way more in depth than we do in our YouTube tutorials. We have a private group where Matthew Reagan, myself, and our other industry veteran and pioneer teachers answer your questions every single day. If that sounds cool, click the link in the description to learn more. And if you enjoyed this video, hit that like button and don't forget to subscribe for more free TouchDesigner and immersive content.